Hi, this is Redis, and Redis is fast, like millions of operations per second fast. That's why it powers caching, session stores, queue systems, and anything that needs to be very fast. Redis is a simple key value database by design. It doesn't try to be general purpose, and that intentional simplicity is a big part of why it's so fast. But that speed comes with trade-offs. It starts with how Redis stores data. Redis keeps everything in memory. This is the biggest reason it's so fast. RAM access is thousands of times faster than disk. No disk seeks, no SSD lookups. Redis just fetches data directly from memory. But this comes with its own downsides. RAM is expensive and durability becomes optional. If Redis crashes before a snapshot or append-only write, data may be lost. On the other hand, disk-based databases are slower, but more reliable and cheaper to operate at scale. Then there is RISP, the protocol. RISP is a tiny, simple text format that is extremely easy to parse, meaning Redis spends almost no time understanding your request. Redis doesn't do stuff like JSON parsing, binary decoding, protobuf interpolation, and so on. Instead, it uses simple markers: the asterisk for arrays, the $sign for bulk strings, the colon for integers, and so on. Of course, that simplicity has limits. Other databases support rich documents, complex types, schemas, and structured queries. Redis avoids all of that to stay fast. And that simplicity extends to how Redis moves data. Redis uses zero-copy techniques to stream data directly from memory to the network without duplicating it. This minimizes CPU work and keeps throughput extremely high. The catch is that Redis must keep its data structures simple, because deep nested structures would break zero-copy guarantees. And Redis pushes network performance further. It can pipeline multiple commands together, sending a batch instead of waiting for each one. This reduces round trips and keeps latency low. But pipelining isn't without complications. Debugging gets harder. Errors are harder to isolate. One slow client can stale the event loop, and Redis has no built-in back pressure. Then there is the CPU model. Redis is single-threaded, and weirdly enough, this is part of the speed, because there are no locks, no context switching, no race conditions. Just a single event loop doing one thing at a time very fast. And the single-threaded model brings real constraints. One slow command blocks everything. Heavy operations are dangerous. Multi-core CPUs aren't fully utilized, and scaling requires sharding or clustering. And underneath that model are highly tuned data structures, like lists, sets, sorted sets, and hashes, each engineered for O1 or O-log and operations. This is great for speed because Redis almost always knows exactly where your data lives. But the trade-off here is flexibility, because you can't ask Redis for complex joins, ad hoc queries, multi-table relationships, secondary indexes, query planners, and so on. In a way, you adapt your data model to Redis, not the opposite. And it all comes back to simplicity. Redis stays fast by doing less. No SQL, no joins, no indexing engine, no multi-table relations, no heavy query optimizer. This simplicity keeps every request predictable. But it also shifts more work to developers. You lose features you would get in a traditional database, for example. So in essence, Redis isn't fast because of one trick. It's fast because of a philosophy. Keep everything simple, predictable, in memory, and intentionally limited. Engineering is about trade-offs, and Redis is one of the clearest examples. Thanks for watching.